I'm not going to read the whole problem, but basically we are going to be looking to find out what the percentage gold by mass is of this piece of jewelry that has a mass of 9.7 grams and a volume of 6.90 cubic centimeters. Also, gold has a density of 19.3 grams per cubic centimeter, and silver has a density of 10.5 grams per cubic centimeter. Additionally, on the next video, I will do a quick little video of how much, to find out how many carats. Obviously, you can see the answer there, but I'm going to show how I can get to that answer. All right, here we go. All right, per what I shared with in class, we are going to start out with the mass of jewelry is equal to 9.70 grams. The volume of jewelry is equal to 0.690 cubic centimeters. The density of gold, just right, DAU, is equal to 19.3 grams per cubic centimeter, and the density of silver is equal to 10.5 grams per cubic centimeter. So, per what I had said before, actually, so the mass of so we're going to say that X is equal to the mass of gold. So also you can say the mass of the gold here. So we started off on the right track. This is different from the paper printout that I gave you, but I wanted to give you a different example. That way you didn't have to just copy, but you can then try it yourself after you maybe take some notes on this. So by default, if we know that from the problem tells us that the total volume of the jewelry is the sum of the volume of the gold and silver that it contains. So we can then say that the volume of gold plus the volume of silver is equal to 6.90 cubic centimeters. By default, if we have the volume is going, you add those two together and you end up with that, automatically you have the mass of the jewelry. The mass will also, if you end up with a mass of gold, it's going to be equal to the mass of silver. Or plus, excuse me, not equal to, but those two plus that is going to be equal to 9.70 grams. So I'm going to rewrite our equation briefly here. So we have 19.3 is equal to the density, which is equal to the grams per cubic centimeters. Also going to do mass divided by volume, or we could just do m divided by v just to make it super simple. So there are many different ways that you can go about doing this. Some of you mentioned that you could do it through the guess and check method. I'm going to do it through the substitution method, which can show your work a little bit better. But again, if you're able to do the substitution method, I looked a little bit deeper, and you can actually use the guess and check method as well. This one, once you kind of get some practice with it, it actually does go a little bit faster than the guess and check. So what I'm going to actually solve for right now is I'm going to solve for this mass, and this is the mass of gold. So this is the mass of gold, so I need to be able to rearrange this equation in order to solve for this mass of gold, and then we're going to actually plug it into some equations here in a moment. So in order to actually make, just rearranging our equation, we're going to end up with the density of gold times, so we're going to multiply this side by volume of gold, and we're going to multiply this side by the volume of gold. So we end up with 19.3 times the volume of gold is equal to the mass of gold. Again, I'm just going to use m in this case. So we've got that much so far. So moving up a little bit. So then I'm going to do the same thing for the density of silver. So we've got 10 point, excuse me, there we go. We got 10.5 is equal to the density of silver is equal to the grams per cubic centimeters equal to the mass of silver divided by the volume of silver. So then again, rearranging the equation, we end up with 10.5 times the volume of silver is equal to the mass of silver. So this is where I got stuck in class the other day. We got this far, and then all of a sudden, my brain just was like, where am I going to end up substituting some stuff in? So what we actually need to do, we have two variables here. We have a volume of gold, we have a volume of silver, and then in addition we have the mass of gold. So how are we going to actually end up moving this all around in order to make this equation work for us? So really what I'm going to be doing right now is I'm going to solve for what the volume of gold is. If I can find the volume of gold for here, I can then plug it in order to find out, using the density, finding out the mass of the gold. So that's what I'm going to do. Makes it mathematically a little bit easier. You're welcome to do it any another way, but I'm going to do it a little. It is a little harder than maybe the guess and check, but again, like I said, you can do this any route. This is the route that I'm going to take. So if I have this equation here and I have this equation here, I can actually substitute a couple things around. So one thing here, if we have the volume of silver, we can rearrange this equation to solve for the volume of silver, just to incorporate the volume of gold. So to rearrange this equation in order to have the volume of silver as what we're looking for, we can subtract the volume of gold on this side and do it on this side, and then we end up with the volume of silver is equal to 0.690 cubic centimeters minus the volume of gold. So we're now going to use this equation to get to substitute in for the volume of gold. So now, we're going to plug this into a full equation. So now, knowing that if we have, this is where our mass and our volume, our mass of gold is going to be figured out, and we're going to use this equation. So here we are, we're going to end up with 19.3 plus, or excuse me, times the volume. I'm going to just put an X because it's maybe a little bit easier than seeing a dot in this video. The volume of gold. And then I'm going to add this because this is going to be, so this right here, this is going to be connected to there. So 19.3 times the volume of gold. And then now I'm going to put in for finding the mass of silver, which we also rearranged to figure out here. But then we rearranged it again in order to figure this one out. So if we have the volume of silver, the volume of silver is also going to be equal to this. So now we have only one variable. We're using what we call the substitution method. So we end up with 10.5 times, we're going to put this whole thing in there for the volume of gold, or excuse me, the volume of silver. So then we end up with 10 times 0.690 cubic centimeters. Actually, I'm going to leave out it's not a very good practice to do. I'm going to leave out our unit for now because as far as leaving enough space. So now we only have one variable. And if we have this right here represents the mass of the gold, this right here represents the mass of the silver. Voila! So if I have the mass plus the mass, I will have equal to 9.70 grams. So then, having this all out, we can then distribute. So I'm going to actually, in this case, I'm going to call the volume of, oh, excuse me, I'll move that up. I'm going to call the volume of gold, I'm going to call it Y. So then we can make it a little bit easier whenever we're writing it. So again, so this number was from there. This right here is what we solved for here. So that's going to represent the mass of gold, of silver, excuse me. So I'm going to end up writing 19.3 y plus, so I'm going to distribute now. Oops. So I'm going to take my calculator. Here we go. And so I'm going to do, so 19.3 times y is that, so then I'm going to do 10.5 times 0.690 going to be equal to, so that's going to be 7.245, and then that's going to be then minus 10.5y is equal to 9.70 grams. I'm going to double check that. So after looking 10.5 times 6.690, I always like to double check. It's a great practice to have. So if you have 10.5 times 0.690, always just double check my work. I'm kind of meticulous about that, so then we always have like a full picture of what's going on here. So then breaking this down, I'm going to solve for y. So I'm going, if I have positive 7.245 on one side, so then I'll clear that out. I will then, and let's maybe combine these two here. So if I have 19.3 minus 10.5, I end up with 8.8y, and then that's going to be equal, so I'm going to subtract, I'm going to kind of do this all combined in one step. I'm going to subtract 7.245, got 9.7 minus 7.245, going to equal 2.455. Solving for y, I'm going to divide by 8.8 on both sides. And I end up with, excuse me as I got a little message there, excuse me. All right. Oh my goodness, I'm getting many messages from my friends of mine. So I get y is equal to 0.28 cubic centimeters. Oh, so there we have our y. So that is then going to tell us our volume of our gold. So if we know the volume of our gold, I'm going to scoot this up a little bit. If we know the volume of our gold and we know the density of our gold, we can then solve for our mass. So here we can plug this number now into here, because remember our y is equal to our volume of gold. So then if I do 19.3 times 0.28, that should give us our mass of our gold times 19.3. So then I end up with, that seems right. Wrong. So I always want to make sure that I have the right number. So if I have 19.3 times 0.28, I still end up with 5.40. And let's check our work. So if I have 5.40 and we have an overall mass of 9.70, so this would be how many grams we have. This is how many grams the entire piece of jewelry weighs. So then our last step, because it's asking for what percentage by mass is it, so we have 5.404. We're going to then divide that by 9.70 and times that by 100. And we end up with, so I'll write that down for you. So then that was, to find out our percentage mass, we do what we have of the gold, that's our mass, divided by 9.70, multiply that by 100%, and we end up with 55.7%. Moving to sig figs, we would then round that to 56%. We could also have an answer, because we have 3 sig figs in each of our problems there, so we could keep it in 57.7. Although the answer in our on the web assign is 56%, but know that you can